Hi everyone, welcome to part 2 of our Frogger mini-series, and in this video we'll be working in the enhanced input system of Unreal Engine to create our control scheme. This is typically how you can define your key bindings for controllers, keyboards, and mice for your projects. Let's not waste any time and just jump right into it. Okay, so we created a input folder. Let's head into there and right click, and under input we have a couple different options. What we're going to be working in today is mainly the input mapping context and the input actions. The mapping context, you can think of them like basically controller schemes. Your projects can have more than one. As an example, you can create a mapping context for your typical player that moves around the world, and then if that world has vehicles and the player gets in the vehicles, you could have a secondary mapping context that contains controls for manipulating the vehicle. And then basically you can swap from one context to the other depending on if the player enters or exits the vehicle. And these mapping contexts can contain any number of input actions that do various things, and you basically can set up the key bindings in the mapping context to actually trigger the various actions. So it's a pretty versatile system, and you're probably going to be working in it quite a bit if you're using Unreal Engine. But I think starting off, let's create our first IMC. We'll call this IMC_Frogger. And we're going to create two input actions. First one we'll call I_movement. And then the last one we'll do is I_leap. So I think for this prototype, the traditional Frogger really only has one real movement scheme. You just kind of use the joystick, and it just kind of moves and hops around the map. For this one, we'll take a little bit of a different approach. The standard movement will work for the car section, but when we get to the river section, we're actually going to implement a jump mechanic, and the player will basically have to time their jumps to hit the various logs and turtles, and I think there's even a crocodile or something, and that way it'll kind of improve or increase the difficulty there a little bit. But let's go ahead and open up our leap. I'll move this over here so you can see it. So the defaults is the value type is set to a digital boolean. For our leap, I'm probably just going to map that to be the spacebar. So this works pretty good. So digital boolean is, true, false, yes, no, on, off, basically. So that works perfectly for a key press. But for the movement, unfortunately, we cannot use a digital boolean. You will typically be using a 1D or 2D, vector 2D for your movement. If your characters are just moving left and right on a screen, you'll be using a one-dimensional axis typically. If the character can move left, right, up, or down, that's typically a 2D. And if you're doing anything with like motion controls or VR, you may be working with a vector 3 or an axis 3D, where you need that extra dimension of verticality. But for this prototype, we're just going to set this to be a 2D, and then we'll hit save, and that'll be good for us. And then we can open up our IMC, and this is where we're going to set up our actions inside of our IMC. There's a mapping button, and we'll hit that. I'm going to assign the first one, which is IA_movement. You can ignore all these other ones. These are showing up because I am using the standard Unreal Engine third-person template, so it has some others by default. But we'll use the one that we created, which is IA_movement. And then we'll hit the plus sign again, and we will add the second one, which was IA_leap. If we expand out leap, that's the simplest one. I am just going to click the little keyboard icon. That basically means it's in listening mode, so the next key I press will be mapped to that action. You can, of course, come over here manually and assign a key using a gamepad or keyboard or mouse, pretty much whatever you want. A lot of these are self-explanatory. Feel free to kind of set up your controllers or your keyboards as any way you want. For this example, I'm just going to use a single key press for spacebar. Now for the movement, we're going to have a few. The first one we'll use is, of course, the W key. And then the second one we can do is the S key. Third one will be the A key. Last but not least, the to round out our WSAD movement, which is the traditional. You can add more mappings if you want. You can use the arrow keys or add your game pads, whatever you need. But what we do need to do is, because this is handling movement across a in our case, a two-dimensional axis, an X and a Y, we're going to have to do a little bit of modification with some of these, because these are true or false, keys, right? You just push it down and let go, so it can't really correspond to, negative and positive values on the X and the Y. So for the W key, what we'll have to do is we'll have to add our first modifier, which will be the swizzle input axis value. And what this is going to do is it's going to tell it to switch from using the X axis, the left and right, to use the Y axis. So swizzle just means basically swap. So we're basically telling it to swap from the X axis to the Y axis, which also means for the S key, we're going to have to add that modifier as well. So the swizzle input axis value for the W and the S key, because those are going to control our up down on our player, and the A and the D will control the left right, so we won't need to swizzle that. Now if you were using a gamepad and you were using like a thumbstick, the thumbsticks can read, at least most modern controllers can read a two-dimensional axis. So it knows if you're going left or right, that's the X-axis, or if you're going up or down, that's the Y-axis. So you would not have to do a swizzle modifier on a gamepad thumbstick that's using the 2D axis. So you could actually get away with that. But we're not, so that's why we have to add these in here. Now the other modifier we have to add is we have to be able to tell it if it's using a positive value or if it's using a negative value. And right now, W and the S key are both reading as positive. So what we can do is on the S key, we can come in and add another modifier, and we'll simply add the negate modifier, which will turn that value to negative. So that's how when we push the W key, the player will move up, and when we push the S key, the player will move down. It'll basically figure out, oh, this is a negative value, I need to go the opposite way. And then the same thing with the A key, we can add a modifier for negate, and then for the D key, we'll leave positive, so we'll leave that one alone. So the D was positive on the X-axis, it'll go right. The A key is negative on the X value, which means it'll go left. And then of course our W goes up on the Y-axis, which we're using the swizzle to do that. And then the S goes down on the Y-axis, and we're using the negate and the swizzle to accomplish that. So hopefully that made a little bit of sense. If we save our IMC, we now have the mapping context set up. We just need to assign it inside of our actual player blueprint. And that's pretty easy to do. So we can come into the event graph, and you can pull off the event begin play and assign it there, but Unreal now has a built-in event for it. It's called receive controller changed. So we can pull off this and do a simple cast to BP, cast to player controller. And then we can pass in the new controller into the object field. And then this gives us access to all the things related to the player controller. So we can pull off that and get a reference to the enhanced input player subsystem. And then from there we can pull off into the built-in function called add mapping context. And we just have to hook up the successful execution pin to this function to run it. And then we just have to tell it which mapping context to use. Now you're going to see multiples in this one because I'm using the standard third-person template, but we're going to use the one that we made, which was IMC_Frogger. And this code here is basically to connect input system. And we can basically give it a color if we want. And that's pretty much it for the controller. Now, doing that really doesn't accomplish much. Like if I hit play and move this over, click in, you can see nothing happens, right? We still need to set up the logic to move the player around, but what this does do is it allows us to actually call logic from those input actions that we created. So if you search input action, you'll see I have access to the leap event that we created and the movement event that we created. So I'm going to do the movement event, and I can split the structure pin, so I have the X and Y. And I think for this example, we'll just come to a simple print string, and then we can basically pull off here. Actually, let's do this. Let's delete, and let's do append. And then what we'll do is we'll say X, and then we will add a pin, connect X there. Oops. And then we can say Y, and then we can connect Y here. Oops. Just so we can see that this is actually doing stuff. So now if we save, we'll go back to our level. And if I actually move or click the various keys, you can see that my X value goes from -1 to 1, depending if I'm using A or the D key, or if I use the W, my Y value is positive. If I use the S, my Y value is negative, and that's perfect. So I think the video is getting a little bit long here, so we'll cut it to keep it short. But then in the next one, we'll actually code the movement logic to get our player roaming around the map. But as always, thanks for watching, consider subscribing, and we'll see you on the next one.